overheating of the protective conductor during a volt. The cross-sectional area of a protective conductor, which is S, shall be not less than the determined by the formula as follows. See here this equation or formula: S equal root I square multiplied by T over K. Or I can use this equation: S equal I root T divided by the K, when S the nominal cross-sectional area of conductor in millimeter square, and I the value of the volt current in ampere, and T the operation time of disconnecting device in second. And also here K is the factor taking account of resistivity, temperature, coefficient, and heating capacity of the conductor material. And also here I can determine the cross-sectional area of protective conductor in according to the line cross-sectional area. See here these tables. Here, if the cross-sectional area of the line conductor less than 16 mm, then I can choose the protective conductor same to the line conductor. For example, if the line conductor is 4 mm, I can say also the earth conductor is 4 mm. And here, if the line conductor size between 16 mm and 35 mm, directly I will choose the protective conductor 16 mm. That means if I choose for 16 mm and 25 mm and 35 mm line conductor, directly I will choose the protective conductor is 16 mm. Finally, if the size of conductor for line conductor is more than 35 mm, here I will divide it the cross-sectional area of the protective conductor by 2. That means, suppose I have a line conductor 50 mm, I will choose the protective conductor 25 mm, and for the 70 mm I will choose the earth conductor 35 mm, and also for 150 mm I will choose the protective conductor 75 mm, and so on. Here, this case only if the protective conductor the same material for the line conductor. And here, if the protective conductor is not same material as the line conductor, then I will choose this equation. Here S for the protective conductor equal K1 by K2 multiplied by S for if the line conductor less than 16, and if it between 16 and 35 mm, I will choose the size K1 divided by K2 multiplied by 16. And finally here, if the S is more than 35, I choose this equation K1 divided by K2 multiplied by S divided by 2, when K1 is the value of the K for the line conductor and K2 the value of K for the protective conductor. And here, if you remember on the chapter of the panel board, we said that there are a circuit breaker called earth leak circuit breaker, or ELCB. What is the earth leak circuit breaker? An ELCB is a one kind of safety device used for installing an electrical devices with the high earth impedance to avoid the shock. This device identifies small stray voltage of the electrical devices on the metal enclosure and introduce the circuit if dangerous voltage is identified. The main purpose of the earth leak circuit breaker is stop damage to human and animals due to electrical shock. And here there are two types of earth leak circuit breaker. The first one called the voltage operated ELCP, and the second called the current operated ELCP. See here this picture for the single phase ELCP. This for line, and here neutral, and here earth connection. It is same like a relay. If any current move through the earth, it will convert to the relay and cut down the circuit. And here this is a three-phase ELCP. See here this diagram for wiring the ELCP. See here this is an ELCP. I connect the line and neutral, and some types have a separate screw to wire the protection earth. But here I connect both the neutral and earth in one bolt or screw. After that I can distribute to my load. And here, if we wanna to talk about distributing earth conductors, for the main distribution panel there are an earthing bus bar. It receives the conductor coming from the earth pit here, and after that I can distributing to my final distribution panel or sub main distribution panel. And also here for the final distribution panel there are small earthing bus bar. Also I'm receiving the conductor from the main distribution panel, and after that I distributing this earth conductor to my final loads. And sometimes I make a separated panel for earthing called the main ground bus bar MGB, and I connect on this main ground bus bar the conductor which is coming from the earth pit, and after that I distributing those conductors to the main distribution panel or the final distribution panel, or I can take those conductors to earth the equipment and the machines.